Hey folks, how's everybody doing today? Man, I had that quiet already. Alright. Let's see. Oh yeah, my volume was up a little bit. Happy Tuesday, hope you're doing well. Got a couple things today, not too much. We're going to finish up Chapter 10, Inheritance, and we'll talk a little more about Project 3, especially the two-dimensional arrays or two-dimensional array lists. I want to make sure we talk about those again. I had a couple questions about that, and then just anything else in general you had about Project 3. And that's it for tonight. Hopefully it won't be too bad. And then we'll get a little bit of extra time, hopefully there to work on Project 3. Make sure you're getting a good start on that before it's due next week, 6/29 at 6 p.m. Right, and the midterm is coming up as well. We'll talk more about that probably next week. We'll take some time to talk about the midterm. We'll do more midterm review on 7/6. So my plan is to give you like the sample one on 6/29, and then I can go over the solutions to the sample midterm a week later on 7/6. And then hopefully it'll work out well, that sort of schedule. So you have time to practice some of those problems yourself, and then I'll go over the answers. We'll do the midterm. And so for Project 4, I'll push that one out. That one probably won't be due till 7/20. So if you want to get it done before the midterm and focus on the midterm, great. If you want to take the midterm on 7/13 and then cram in Project 4 in a week, that's up to you. But we're going to start it next week, so there should be time to at least get some good progress done on it before the midterm. But then you don't have to worry about finishing a project and studying for a midterm all at the same time. So you get a little bit of extra time there. Plans for the midterm itself. It'll be a desire to learn quiz that you can take. I'm just going to open it up 7/13, say at midnight in the morning, and then up until 11:59 p.m. you're welcome to start it. It does have a 4-hour time limit though, so once you hit start, you have 4 hours to hit submit. So if you're more awake and alert in the morning and you've got a good block of time to take it then, go for it. If you want to take it our usual 6 to 10 slot, go for it then. Totally up to you, whatever's going to work best for your schedule and for how well you do on exams. It is open book, open notes, open internet, not open neighbor. You do not get to work with a partner on this one. But aside from that, it'll be essentially half quiz style questions and then half short answer programming questions. Like, do this little thing, do this little thing. Nothing super large, because I know trying to program something under time pressure is always awkward, but it'll probably be like 3 questions, one about classes, maybe one about inheritance, and probably exceptions in file I/O. So advanced file I/O is likely the other question. So I'll give you some examples of what they might look like: a classes question, an inheritance question, and an advanced file I/O question. So nothing large, but something you should be able to get done in a short block of time. Just a quick little write something that does this. And that's the plan for the midterm. So we'll talk more about that. I'll have a sample for you next week we can talk about, and then on 7/6 I can go over some answers to the samples, and we'll pick it up from there. And then on 7/20, after the midterm, we'll come back and we'll get back into Java FX for our graphical user interface programming, and then we'll talk about the final project, and that is it towards the end of the semester. And we'll have a little bit of talk about design patterns on 8 to 10, just some little extra. This isn't content from the book, just some notes. And then some extra time to work on the final project, and then we'll present together on Zoom on 8/17. Each pair can present. Ideally, you're going to pair. Again, I won't require it. Just I know this online learning stuff is a little crazy sometimes, but hopefully everyone has found a partner they can work with, and we can go from there for that. Does that sound like a good plan? Is anybody there in chat? Let's see. Let's say anybody's around. Yeah, it says there's people around. You're just quiet in chat. That's okay. Maybe you need some more coffee. All right. Hey there, Nav. How you doing? There's more coffee? All right. And I did want to update this. Hey, Brightside. All right. Awesome. Glad there's a couple people out there in the world. Let's see. I had mentioned trying to cut back on the coffee. That might be good, given that it's 6 p.m., but some people need the caffeine all the way through. So you are allowed to work with a partner on this one. This project. Just let me know who you are working with. Please both submit individually. If you don't submit individually, it makes it hard for me to know to grade it. And as you can see by not having the first project graded yet, I apologize. Grading things is difficult for me. So you want to make that as easy as possible for me, please. I'll be getting to these as soon as I can. That's been on my to-do list. Unfortunately, it was a rough day for me. I had to go to the doctor. Just my regular checkup, but anytime they do blood work, it's awful for me because I have this really bad vasovagal reflex, which means I usually pass out. And then it just makes for a miserable afternoon. So I did not pass out this time, but I got really close. Did not feel great. Almost threw up. It was uncomfortable, but better than passing out totally. So I guess that's a win. All right, let's go back to that assignment. Oh, I was just on that. I wanted to look at the assignment here. So again, this is meant to be somewhat open-ended, right? Any way that you want to implement these sort of tools, right? Dig, build, chop, some sort of whatever options you want to have on your tiles here. Your island just has, it's the two-dimensional grid, whether or not it's a 2D array or it's an array list of array lists, perfectly fine. Something like is buildable, is diggable, is choppable, those sort of things. We're going to use interfaces, right? And then so your space will implement that interface if it is one of those, and then try to let you do that thing on that island. So they'll be able to take that action and then modify the island's description or something. Hey, thanks so much for following along. Nice to have you here. And then you can move around your island, travel to your friend's island. So some sort of menu, right? Right, the player class, the island class, our interfaces, the space class, the tools, friend functionality. So none of this actually requires you to be able to play the game. Okay, what we're doing is we're building the classes here that can be used to build the game. Because building it as a console text-based game is going to be, it'll work. It just won't be as neat looking. But if we can take this and put a GUI application on top of it, where you actually have like some graphics and buttons to click and things like that, then all of a sudden it makes a lot more sense. So there's no points here, right, for actually having some sort of main method with a loop that says, hey, what do you want to do? Do you want to go up? Do you want to go down? That's how we would interact with it. But what we need to do is we need to have these classes. Right, our space class, they have random tools or implement interfaces. Our interfaces have all their methods. Our island class is the 2D grid of spaces. The friend functionality, right, we can visit a friend's island. So how do we go to a friend's island? How does an island know who's on it? That sort of thing. Whether or not we can edit someone's island if their friend, right, if they've given the special permissions to their friends. So like you don't get to edit the friend's island. You can navigate around it, but you can't edit it if you're not a particular level of friend or something like that. That part makes sense? So hopefully that makes it feel a little easier to swallow. And if you already spent a bunch of time making it work, I apologize. But in terms of the rubric itself, it's the classes, interfaces, classes, tools that actually will do something. So ways that we interact with the classes here in this friends functionality. So none of it was actually running the game. It's going to be difficult for you to test unless you do a bunch of unit tests. Unless you build that main method, right? Or how do I make all these things happen? But that's okay. We can worry about that another time, right? What we want to focus on is how do I have classes? How do I have interfaces? How do I check to see if I can do these sorts of things? How do I see if does it implement this interface or not? That sort of stuff. Does that make sense? All right, let me fire up NetBeans and let that load for a second. So like each of the is buildable, is diggable, is choppable. Right? This idea that we're having a bunch of interfaces that a space can implement. So if this particular space has a tree, it would implement is choppable or something like that. And the description of the space would start with like, it's a beautiful space with a tree in it. And if it implements is choppable, you'll have that chop method. And then once you chop it, it should change the description to now there's a tree stump or something like that. Right? Anything you want to come up with, it just it doesn't need to be super deep and complex, right? The idea is we just want to be able to have this interaction between classes that implement interfaces, checking to see if it implements interfaces, having specific tools, like the tool class that can do certain things if the space has that. It's like you can't chop unless you have the axe tool, right? So the axe tool works with the is choppable, right, to be able to chop, that sort of thing. So just trying to take a bunch of different pieces here and kind of fit them together with how we get all these connections happening here. Does that part make sense? I hope. All right, cool. Yeah, and again, the points are coming off the rubric here, right? So for the player class, right, the player needs to be able to have their bunch of tools. They need to know where they are. Maybe the island knows where they are, right? Or the player could have the island that they're currently on as a reference, that sort of thing. Okay. If you want to add silly stuff like sleep, I don't know, sure. It's buildable. Maybe you can change the space. Sure, why not? Pitch your tent. I think is that what you do? You pitch a tent in Animal Crossing. My kids play it a lot, and I have yet to actually master how that all works. Any other thoughts or questions on this one? You haven't played since GameCube. That's right. It used to be like this was the latest iteration, right? The New Horizons. I didn't realize that. For some reason, I thought this came out of brand new nowhere. But I didn't realize this was new. But aren't they getting a lot of flack for like it's been popular for a year now and they still haven't done some common easy changes that they should have done a while ago? I don't know. That's every game. You're saying there are no new games at all? It's a little depressing and makes me, I don't know. Maybe that Game Pass actually is a really good deal because then you get to just try all the games and you don't have to sink a bunch of money into buying them. Oh, every game has issues that should be fixed. Oh, it'll take forever. Yeah. Uh, it, Software is hard. It really is. It really is. But yeah, I feel like we could do a better job prioritizing stuff that's just like easy quality of life improvements to make our players happier. But again, I don't work in the game industry, so you know you can get into the game design program if you're curious and learn more about it. I know we've got a couple programs in the area that are pretty well respected in terms of game design. So I'm sure one of them would know much more about it than I would. But I don't know, just as a general developer, like really, that's it. All right, cool. So let's take a look here. I think I finally got this loaded. Let me close that down. So here, let's do this. Let me start up like a shell 2151. I'm going to call it Project 3 just to explore, like, here's the two-dimensional array list or two-dimensional array of a class. All right. So we'll start this off. It's not going to have much of anything in it, but I just want to like show you how we can interact with these sorts of things here. Right. Okay. I guess I'll leave that to you. That's fine. So if we add a class here for space or, I don't know, square or something, I don't know, whatever you want to call it here, right? Sure. That's it for now, space. You know what, let's add a I don't know, private string for description. And then let's add a getter and a setter. Insert, setter. And why not add a constructor? Right? We're going to let all this code happen here. So, sure. All right, I like that. And then, you know, just for fun, why don't we do another one here? Space. If you give me no arguments, then we'll just say this with like an empty string. Why not? So just empty description. Remember, you don't want nulls. Nulls are the worst, right? So you don't want any object to be value of null when your constructor's done, because your constructor's job is to set values for all of your attributes. Okay? Even if it's a empty here, it's not null because it's an empty string. So later on, if I try and use description, like get description, it won't be null, it'll be empty. Okay? So sure, this is a space. Again, there's more things space needs, right? This is not the end space here. I want something and I can have a description to play with here. And then say for it, I have like an island class in island. You know, I found out how they named island. They came up the name for it here. Right? This was a really cool story. So you're out here in the water, right? Here's some waves. We'll draw a little boat here, right? Here's our sail in the wind. That's actually a halfway decent boat there, right? Right, sure. It's got a pointy end here. We got some people on the boat, right? And the people are looking around, and this here, you know, the water is not land. It's water. Okay? See this little island over here, right? With a nice little palm tree growing on it here. Little palm fronds. I don't know how to draw a tree. A terrible artist, but it doesn't stop me from trying anyway. And it's got a coconut here, right? Coconuts. Sure. Okay, that's terrible now. Forget it. I should have stopped with the palm fronds here. Here's our island. They're like, hey, that is land. This is not land. All right, so we got our little island here. And do you want to do an array list first or a two-dimensional array? I can do either one first. Thank you for laughing at my terrible jokes, Nav. I appreciate that. When we're all on Zoom at the end of the semester, I'll get a chance to watch those of you who want to turn on your cameras. You actually like groan and shake your head at me at my terrible jokes. But for now, I get to imagine it. So does anyone have an opinion? Should we do array lists or just a regular array first? I like array lists, so I'll do array lists. So an array list, to make it two dimensions, is an array list of array lists. Right? So this is the, I don't know, the grid or something. Sure, why not? And yeah, okay, please import my array list. Thank you, NetBeans. So public island. Now grid needs to make a new one. Needs to be a new array list of type array list of type space. There we go. Actually, it should let me do... Oh, does it let me do the diamond? I don't know if it lets me do that. Nope. I think it needs to match because it's two-dimensional. The diamond operator gets a little funky sometimes. Okay, so now I've instantiated it, but it's empty. Right, so now I want to, for every row, right, for int row index 0, row index is less than, I don't know if you want to do like 10, sure, row index plus plus. We're going to take my grid, and we're going to append a new array list of type island. So this is the row that's being added. Right? Then what I could do if I wanted to, I could say for int column index is 0, column index is less than, I don't know, and it doesn't have to be a square, right? This could be like 12 if we wanted. It doesn't really matter here. Column index plus plus. Then I can take my grid dot get the row index dot append a new space, given, you know, random space here. So it's going to add a new row, and then I'll add 12 spaces to that new row I just added. Right? And then let's just do it like a silly two-string here. String, override, come on, work with me. So is it doing it? Why is it not doing it here? Why is it unhappy? It's unhappy. I don't know why it's unhappy. That's fine. So let's do a string builder. Builder equals a new string builder. Builder. I lost. It's not doing anything. Come on, NetBeans. What is it doing? Like, I'm not getting my... No? Okay, sure. And then we'll say for... Now this is an array list of type space called the row in the grid. So for every row in the grid, let's do something. Or, you know what? Maybe I want some numbers here. So we'll do the indexes again here. So for row index is 0. Row index is less than my grid dot size, and my row index plus plus. And then I do the same thing for column, right? But now I want to go less than, this is my grid dot get row index dot size. Because remember, getting the row index here gives me an array list of type island. Size will tell me how many columns are in that here. Right, as a two-dimension, as the second dimension here. Okay, and then maybe we'll take my builder and we'll append, I don't know, row, builder.append, the row index, builder.append, space and a column, and builder.append, the column index, and then builder.append, maybe another colon or something, sure, why not? And then builder.append. Now, if I want to get that individual space out, it's grid.getRowIndex, which gives me an array list of type space, .getColumnIndex, right, which gives me the individual space, which then I can say get description on. And then builder.append, how about a new line? What happened to my, like, there's not, why is it so upset? I just want to build it. Like, it's not giving me anything. I should get some sort of errors or type of heads, or I don't know what it's doing. I don't know why it's confused. Okay, there we go. Now, okay. Incompatible types. Array list of type, oh my goodness. That's where I screwed it up. It's not of type island, it's of type space. All right. That one error there. Now I couldn't get anything else. Isn't it dot append? Is it add? It's add. Sorry, add. Of type space, not island here. There we go. Okay. See, it's so much nicer here when you get the red errors here. It was so confused. Like, it was just wrong, and then it just yelled at me the whole time. Didn't give me a red line. Anyway, and then when we're done, we're going to return our builder toString. So ours are, again, a bunch of random spaces here. It's not super interesting, right? So maybe we do something random. Why not? Let's do something random for fun. Random equals a new random. Space here. We need a string, so let's do random.nextInt. I don't know, like up to 100. Oh, let's go up to 1,000 and .toString. But there needs to be a string. Random space. Oh goodness, that gets a little long there. Int. Okay, I can't toString that. I need integer dot toString given the random index. There we go. That dereferenced error was saying because, hey, that wasn't an int here is not an instance of the integer class. It doesn't do that boxing for us quite as nicely there. Right, so any int, you can't dot anything on it. All right. Is that any better, or is that just almost looks worse now? Okay, that's where I wanted to put it. That makes sense. So this way we just get a random space and put a random number in here, and we should be able to get one out here. So then I can make an island, right? Island, island, equals a new island, and then island dot, or just print out the island, right? Because that's the toString method. And it ought to show us our island. Again, it's not going to look like a grid here, but we didn't put it in grid form because it's not going to line up right. And I guess these 3-digit numbers not really going to line up correctly very well. But imagine it's a grid, right? Sure. And we can see we have a bunch of random spaces. So this is the array list of array lists of space. So a 2-dimensional array list, right? Where what's contained inside of it is essentially all the rows. And each row then has all the columns. You can imagine it that way. So the bummer part about this way is you have to add them individually. Remember, if you make a 2-dimensional array, you already have the indexes there. You can just go set them. You don't need to add new spaces. You just set them to be a new space. But again, it's not too bad. That's fine. Does that part make sense? So we could just generate a random grid. Again, you need something more random here. Or maybe the space class itself then could have a way to generate something random here. If you give it the no argument constructor, maybe you get a random space and it might have a tool on it or might implement. It's harder to implement the interface there, right? So if you're going to implement the interface, you need a subclass of space that implements an interface. Hydration, thank you so much for the reminder. This is the knockoff Perrier LaCroix. I guess it's not even knockoff Perrier. It's just, I'm sure it is, right? Huh. And they're their own company. LaCroixwater.com. They're not owned by, like, Coke or Pepsi? I did not know that. That's really interesting. I thought there were only like 2 bottling companies left in the country. I mean, it has a hint of lime flavor. It is not lime flavored. There's a hint of lime flavor. They say it's like a sparkling water truck that drove past a lime truck. But sure, it's fine. It's bubbly, which I prefer beverages that are bubbly now. Canned TV static. Superior to Perrier. Ooh, those are some fighting words there. They're gaming senpai. Yeah, I mean, sure, it's what it is. You're not getting it because it, is amazing lime or anything like that. It's some flavored sparkling water. Excuse me. So for space to implement an interface, right, the space class does not. Right, we'd have to have a subclass of space that implements an interface, but they can be treated, right, as a space if they are a space. So the description part can change. But we need to see if they implement the interface. We'll talk a little bit more about that tonight with some other examples. I don't want to do too much here with the project example. I'll leave that for you folks, but this little 2D bit, at least, you can have some fun here. Okay? Let's see. So let's open up our project 10 here. 51. Chapter 10, Inheritance. We open that one up. See how far we got. Yeah, circle, cube, cylinder, the has volume interface. Okay, cool. So you're implementing an interface. Right, we had a list of has volume interfaces. Oh, that's sure. It's all well and good. Let's see, our rectangle, our square. We didn't add any of the ones that have volumes there, right? We didn't add a cube. Let's add a cube here. Oh, no, we have a cube here. Okay. So, for fun, let's take our shapes here, and we're going to add my 3-dimensional shapes dot get, and that should be 0, right? So, 3-dimensional shapes getting 0, right, should be the cube here. Oh, but it says, the types don't match. Has volume interface cannot be converted to polygon. Well, let's cast it as a type polygon. Because I know a cube is a polygon. Right? Sort of. Because a cube is a square, right? And square is a rectangle, and rectangle is a polygon. So cube is sort of a polygon. I know that's kind of a little funny here, but that's okay. Sure, why not? You could try that. And we'll go for a loose list here again. And we should now get our QB out. QB, perimeter and area. Sure. You can do that. Okay, let me grab, no, not that one there. Page here. Actually, I'm not missing anything here. Give me just half a second. Excuse me. All right. So we talked about the is-there relationship, our fields, our methods, our constructors, overriding. Do we talk about the protected versus private here? Don't think we got that far, did we? So if you want your subclass to have access to it, instead of marking it as private, you can mark it as protected, which means only you or subclasses have direct access to it. So and maybe then it would be easier if our side lengths was protected. But again, we've already kind of worked around that using the set side length here all the time. That's fine. There's also a thing you can do if you don't want a method to be overridable here. If you don't want a subclass to be able to change it. Again, none of these examples make a whole lot of sense for doing that, but that's okay. You could add in it's called the final attribute. So like we're able to make attributes final. Say, hey, this is a final integer here. I'm going to set it once in the constructor and I'm never going to be able to change it again. You can mark methods as final so that they can't be changed. So I could say, hey, this is the final version of getPerimeter, and now you can't override getPerimeter. So if I wanted to, over in Square, try to add override the public int getPerimeter, it's going to yell at me and say cannot be overridden because overridden method is final. So it prevents you from overriding. No. Source toggle comment. There we go. Control slash. That was it. Can't do this. Can't override something that is final. So it's kind of weird we use that final keyword for both, but that's okay. Right? You are able to do that. Protected and public. We get our inheritance. Yep, we did the polymorphism. Okay, yeah, we got pretty far on this. Good. Good. We talked about abstract classes, where our polygon here is abstract because we say, hey, you should be able to get area, but I don't know how to define that as a polygon. When you extend polygon, you'll be able to get area. And what that means is you can't have instances now of just polygon because it's abstract. And then we looked at interfaces. Interfaces are essentially a purely abstract class. All it has is abstract methods. Essentially, that's all it is. You can also have sorry, looking for the right words here. You can have a field. Yeah, you can. So that one's maybe not quite as common, but they're essentially a final static field. So like you can set, hey, here's a value for it. I don't know. If we wanted to have like our own pi, sure. Pi approximate 3.14159 or so, right? it's essentially final and static. Is it gonna... Oh, sorry, double. Yeah, why would that be an integer? So it's a static because it belongs to the class or interface here, and it's final. I set it once and I can't change it. So fields are usually kind of silly to have. You know, every now and then you'll have them, but that's not as common. Okay. You got fields, polymorphism. The idea with polymorphism, right, that I can treat it as its parent type. Oh, that's it. Okay, so you can have a default method in an interface. Again, that's probably not as common. Where you say, hey, this is the default here, but yeah. That way you can modify the interface and add a new one. If you add a new method, you say, hey, here's the default. It's, I don't know. I think it's a little bit ugly. All right, but let's look at how we can check for polymorphism here. So let's look at our chapter 10. Okay, and now we're going to, as we loop through shapes here, let's say if shape dot, here we go. Now, get class returns the runtime class. So this is the actual instance here of the class. Okay, let's print that out too if we can. So we'll say actual class plus shape.getClass. And then when we run this one here, it should toString. Yep. So my QB here is actually a chapter inheritance cube class. Right? The square is a square class, the rectangle is a rectangle class. So you can get the actual class type out. Right? Remember, this is the runtime. We're treating it as a polygon here. But what it actually is, what its runtime class is, and that Java knows about, is this one. And that's how that polymorphism works. Right? As I call get area, it will give me the correct get area. Right? Cube doesn't have one. Right? It gets it from square. Well, square doesn't even have one, right? Square gets it from rectangle. Rectangle has a get area, which is just length times width. Okay, so if we want to see what the actual class is here, we can check it. Okay, does that part make sense? Other cool things you can do, right, with the class here. So we're going to look at that cube one here. So this is our, you know what, let me just make it as a cube here. So cube equals this one here. We'll add the cube, and then maybe it's easier to just add a cube here because we don't have to do any of that casting. Okay. Now what I can do with cube, right, you can do this get class thing here again. Once you have the class, you have a whole bunch of things you can do with the class, which is super cool. One of them here is get interfaces. Gives you an array of classes, which are the interfaces that it implements. Right? So I will say, here's my array, my class array. This is my interfaces of implemented by cube. And then I can say for class, or I don't know, it's the interface implemented in the interfaces implemented by cube. We can print out the interface implemented. That's not spelled quite right, but that's okay. You understand. And we can say these are interfaces implemented by cube. And it's the has volume interface. Isn't that kind of cool? Cool. So then the other thing we could do then, right, you can check, we can say if so I want to check to see, does it implement this particular interface? So I'll say, here's my has volume interface, and I want the class here. So this is the actual class definition of has volume interface, and I can say is assignable from my cube.get class. And if it is, we'll say cube has a volume, or implements volume. I don't know, sure. So if you have a bunch of shapes here, what we could do then in here, we can say if my my has volume interface as interface class dot is assignable from my shape.get class, then I can print out the volume is, well, now I can't do shape.get volume, right, because it's not there. I need to cast it as that type. Oh my goodness. So I can say has volume interface is the type here. Volume interface. My type ahead is failing me today. Has volume, no, just a parenthesis. Has volume interface of my shape. Right, cast the shape as a has volume interface dot get volume. So if it is assignable from that class, then I can treat it as this interface type. So I can see my volume here. Hey, how you doing? Priyansh 4610. Look at that. I'm learning to be better at pronouncing Twitch names. It will definitely take me some practice, but I will get there. Okay, so if we're looping through the superclass type here, we can see, hey, if it implements a particular interface, then I can do something with it. So like when you're dealing with subclasses of space here, so you might have a diggable space or a buildable space, or I don't know, whatever silly ones we came up with, right? We can check to say, hey, if it actually is that type, right? Because we're only keeping the superclass space as what we're treating them as. So we can check to see at runtime if they fit this match. Does that help with how we're going to deal with our spaces? And some of them will implement interfaces and others won't. Right? Because your class either implements the interface or it doesn't. All right, so no yeses, no nos, just quiet. And that's okay. It's a weird way of thinking about code that we haven't really done before. So we're like treating code polymorphically as the parent type, but we can also see what it actually is and if it fits as an interface type or other type here. No, that's fine. That's fine, Ev. And this is where I miss out. Being an in-person class, I do. I eat my own eyebrows or something. Sorry. Um, we could spend a little bit of time talking about it and then try it, on your computers here. It doesn't translate well to these online formats here. And I really don't want to try Zoom breakout rooms, if that's okay with you folks. Yeah, so if we were in person, like we could try it, so go use the lab computers, do some stuff. I could walk around the room, process it, and then we could keep on lecturing. We being me, I'm sorry, I'm weird. I could keep talking, but it's much harder in this online format. And I really, oh, the eyebrows. Yeah, I don't know. I had a hair in my mouth that looked like one of my eyebrows fell. I don't know, Nav. I'm losing it here. It's one of those days. One of those days, friends. Yeah, we're halfway through a summer semester. Like we are legitimately halfway through a summer semester. This is crazy. And it's actually the first day of summer, and we're halfway through the semester, right? Um, well, it's a little weird for me, but that's okay. Because I guess we start the fall semester in the summer too. This fall doesn't start till end of last of September. Yeah, this is 7 weeks here. There's just seven more plus our final week, right? The final project work presentations is not really like, I'm not lecturing at least. So in terms of content, we are more than halfway through the content now because we have chapter 11, 12, 13, and 14, a little talk on design patterns, and that's it. So 1, 2, 3, 4, 5, 6 more nights of content, essentially. And the design patterns won't take us all that long. This is only about an hour chat, just to introduce some of these things. All right. Yeah, other questions, thoughts, concerns? All right. I don't know what that emote means, but it looks super cute. Is that a little like something eating pizza? Huzzah, pizza? Nice. That's awesome, Professor Burp. An octopus eating pizza. Okay, I like it. I think octopuses would like to eat pizza. Um, they're actually like one of the freakiest looking animals out there. In terms, like if you've ever seen them eat anything, I'm like actually slightly terrified of octopuses, octopi. There's one at the zoo that was super cool, or an aquarium that was super cool. It would just kind of like pulsate. It's like freaky. Definitely suspicious. Definitely suspicious. Yeah, does this get you further along in working on Project 3? That was the goal. Actually, that's pretty much the rest of Chapter 10 here for Inheritance. Dab. For sure. Yeah, if I do the other direction, though, I hit my hand on my little desk thing, my loft desk here that I took for my son when I had to move into a home office. He was hitting his head on it anyway. He did not like sleeping in it. He was getting too big. Oh, I know. The emotes are a lot of fun though. Like especially the the people who care about their emotes and put a lot of work into them. They're super fun. I think it's one of the cool things here. And all I have is my little coffee one, but I was proud of that one. So versus C++. So C++ allows for multiple inheritance, which is really ugly. So in Java, you can extend a single class and a single class only. You can implement as many interfaces as you want, but you can only have one parent class. Other than that, it works very similar. The override annotation, you would actually put into your code is not an annotation. You would declare it in the method definition there, 303. Multiple inheritance is just confusing and awkward, and it's generally frowned upon in object-oriented programming. Yeah, for sure. Like the order matters because because you get all the methods that your parent class has. So if you extend two different classes that both have the same method name, it gets to be a little confusing as to which one's actually going to run. And it's whichever one you extend first. So Java is much nicer, C# is much nicer. You only can extend a single class with that parent-child relationship. So you only have one superclass. Now your superclass can have a superclass, which can have a superclass, which can have a superclass, right? Like cube is a square, square is a rectangle, rectangle is a polygon. Polygon is an object. Remember, everything inherits from object. Implicitly inherits from object. That's how we get our default toString. Right? Polygon doesn't know how to toString itself. Rectangle doesn't know how to toString itself. So if we try to print those things out, right, with just printing the shape, we get garbage. Remember that default toString is, hey, here's where the thing is at memory. Where am I doing it here? Like here, chapter, that's the class at essentially the memory address. Yeah, so an abstract class is great if you know that you will have some kind of method, but you don't want to specify it because you don't actually know how. So in a polygon, just a generic polygon, you have no idea how to calculate an area for any generic polygon. There's just no formula for area for a generic polygon. But I know I want to be able to have an area here. So I'll say, hey, when you extend polygon, you have to have a method named getArea for you to be a polygon. And then if I'm a rectangle, I know the formula. If I'm a trapezoid, I know the formula. If I'm a triangle, I know the formula. I'm sure there's formulas for all the other ones too, but I have no idea. I could not tell you those ones. Right, so we can say this is an abstract class. I know here's a lot of common functionality. Right, all the things that are the same here, great. Name is the same, get side length, set side length, that's all the same. And then if I want, when I specialize, when I extend it, I can override those if I want to, or I can add new functionality. Right, when you extend a class, you're doing it because you want to add additional functionality. So if we didn't define it in Polygon for getArea here, when I just treat them polymorphically and say, hey, I've got a bunch of polygons, there would be no getArea method. We'd have to do this nonsense to say, hey, if it is something that has a getArea method, then we could go call it. But because the parent class has the abstract method getArea, we know if you're a polygon, you will have a method named getArea. So we can do a quick loop, and we can use the getArea method because the correct one will run. Awesome. Good question, 303. You get some bonus points. Sorry, they're not actually worth anything, though, but... Yeah, and this sort of stuff with interfaces and abstract classes is why 2151 is recommended before 2353, the data structures course. But it's not a prereq. It's just a recommendation. So it's a little bit awkward. Apologies. And if you're in both classes, then hopefully now some of that makes a little bit more sense because we did the Cliff Notes version to get us up and running using interfaces in data structures. Or maybe you're bored now because we've already talked about it. That's cool too. Yeah, so like our has volume interface. Again, this pi approximate, this was pretty silly. I'm going to comment that out. This is usually silly. Yep, so it's essentially a purely abstract class. It only has abstract methods. Let's find abstract methods. You know, you can have these fields, but I'm sure someone has a good use for it every now and then. That's otherwise they wouldn't have added it. But usually, I'll say not necessary. How about that? Right. So as we look at our island here, right, we add an interface like is diggable or something. Diggable. Why not? And then it would have public, I don't know, boolean dig, and it'll tell you true or false if it worked or not. Well, so you can implement as many interfaces as you want, but you can only extend one class. So if the is a relationship makes sense, if you are a type of your parent class and you're a special version of it, inheritance is the way to go. But if you're just saying, hey, I fit this bill, I agree to this contract, I will have all the methods listed in the interface, I'll implement them. And you go with an interface. So then we can make a new class here that is a diggable space, right? And this would extends space, so it is a space. Now, remember, if your parent class has a constructor, you have to call it. So cylinder has to call the superclass constructor. Now, space, though, has a no-argument constructor. A no-argument constructor doesn't need to be called because that's the default constructor. So a diggable space, by default, will call the no-argument space constructor. If you want, you can call the one with a description. Totally up to you. It's totally optional. And if that's how you want to do it, go for it. So if then we would implement is diggable. And it's going to yell at us and say, no, we don't. And we're going to say, yes, we do. Please write the code for me. And again, it gives you a junk one here, but that's fine. I need to fix up those templates. And then dig then would change the description, right? We could say like change description or set description to you dug a hole in the space or something, right? I don't know. You come up with it, right? And then return true. Return true. Right? Or maybe we have to check, hey, do you have the right tool? Do you have a shovel? Well, if I'm checking if you have a shovel, I need to know who's digging. So maybe you'd have to pass it to the player. And then we could say, hey, player, do you have a shovel? And if they have a shovel, yes. If they don't have a shovel, no. Sure. Yeah, we haven't done any unit tests for this one. We did unit tests before. It was nothing we did this chapter with inheritance, though. Yep. They're all on my GitHub there, Terraform. Or Terroma, I'm sorry, Terroma 303. Exclam GitHub there in chat. We'll give you the link. We've done a lot with unit testing. We just talked about that actually last night with the 1500 course. Right. Any other questions, thoughts, or concerns? Right. So if we wanted, like, do we want to add a player here or something? I don't know. Sure. Why not? Why not? We'll add a player class. I don't know. And sure, we'll add a public boolean can dig. Return true. Again, this is not, you check if you have the right tool, this, all this sorts of stuff here, but in your diggable space, if you want to dig, say, hey, here's the player. And then if player.canDig, right, then we'll do this. Otherwise, we'll return false or something. Right, lots of options here. Lots of ways to go about it. Uh-oh, what did I do? Oops, now my dig method's wrong. That's right. I have to change the dig interface. Is diggable, should accept a player. Now it's happy with me. Right, so if you tell it what player wants to dig, go for it. Or, hey, are they on their home island? Are they on their friend's island? Right, this read-only sort of operation. We have a little bit more complexity here going on, right, than just, can they dig? So can dig maybe also needs to check if they're on their island or if they're on a friend's island and they have the friend permission, that sort of thing. We have all sorts of like this chain of this class talks to this class, talks to this class, so they interact and know if it's the right thing to do here. Okay? Is that helpful? Looking at the project again, I want this one to be a success for you folks. I have big plans for this project, or Animal Craft. We don't want to get any trademark trouble here. We're just having fun. This is academic practice, right? All right, so let me commit all this here to GitHub. All right, so if that's all we got, then why don't we head on over? 303, you're talking about like Spring, the framework? It's just a framework for implementing Java. It's nothing we really cover in class, sorry. Why don't we see who's around, and we'll send a write-off somewhere. We'll have a little extra time to work on Project 3. I've got office hours tomorrow, 3 to 4:30 and 10 to 11 p.m. If you folks want to drop on by and chat, happy to talk. So who is around? Oh, not that many people around. Do you want to watch a Kerbal Space Program with Rocketology? Go do that. That sounds like fun. All right, folks, take care. Let me know how I can help. And work with your partner on this one or chat, see what I can do to help, and we can go from there. Did it not go? I thought I clicked the button. Oh, there it is. Yep. All right, folks, take care. Let me know what I can do to help. I'll see you next week, and we'll go over the solution to our Animal Craft game. Take care.